solution is easy like this. Look what I'm doing. It says the length of the ladder is given 16 feet. It's 30 degrees, and here we have a V, A, and A. That's point A. Point B is question. VB, AB. Besides, it wants to know alpha of AB. Is that right? Yes. Angular acceleration of that. Look what I do. I set x of A squared plus y of B squared is equal to 16 squared. Is that right? So what did I do? Forget about the problem. It's a geometric in motion. Geometry in motion. Write the equation for that geometry which is here. X of A plus y of B squared is 16 squared because we have a triangle. Now I'm taking derivative of that equation. It says 2xa VA plus 2yb VB is equal to 0. Is that right? So it means you need to find XA. XA is equal to 16 cosine of 30, which is equal to YB is equal to 16 sine of 30, which is equal to 8. Give me the first one.
13.86.
Again?
13.86.
Meter. No, feet. Feet. Substitute back here, we are looking for VB. So VB is equal to 2 XA VA divided by XB, which is equal to 13.86 divided by 8 VA. VA is given something. VA is 6 feet per second. So 6 feet per second multiplied by that, give me the number. Again? 7 point?
10.4.
8 point? No.
10.4.
10 point. 10.4 feet per second. Tell me how I can find acceleration of B. First, is that clear? I didn't explain. Yes, no, if you want me to explain, ask me. If it is clear, then I continue. That problem was possible to write an equation for a triangle which is in motion. I don't mind. Whatever is the length here and length here satisfy that equation. That equation connects position of A to position of B. I take a derivative. It is derivative respect to time. It is 2x x dot 2x dot plus 2 y of b y dot, which is v of b. At this configuration, we have 30 degrees, so I'm able to calculate x of a, y of b, substitute back, VA was given to me, so VB is calculated. Now, Iskandar said, goes here, go here, and take another derivative. Another derivative, it's 2. Let me write that equation again. It is 2xa, x dot a, plus 2 yb, y dot b equals to 0. Is that right? It's the same equation, right? Instead of v, I put dot because I'm going to take a derivative of that. Look at this. It's 2 x dot of a, x dot of a, plus 2 x double dot of a. These two are derivative of that term. Yes? Derivative of the first one times second one, plus first one times derivative of the second one. Same thing goes here. 2 y dot b, y dot b, plus 2 yb, y double dot b equal to 0. Now I translate everything to this. 2 VA squared plus 2 XA AA plus 2 VB squared plus 2 YB AB equal to 0. Well, cancel 2. What am I looking for? I'm looking for AB. What do I have? I have everything. So, AB is equal to 1 over YB times what? Times VA squared plus VB squared plus 2 x a. There is a negative somewhere, which is not important. Y was from here to here, velocity is downward, acceleration downward, so we get negative. Substitute the numbers. It's gonna be minus 1 over YB, which is 8 times VA. VA was given to us, 6 to the power of 2, plus VB 10.4 squared, plus 2XA. No, there is no 2. There is no 2. I cancel 13.86 times A of A. 4 times 4.
你懂我左塞曼哦，
Give me that number.
我从看他的 video 哦，他甚至有差不多 almost 10次这样。不明白。不明白
Number?
什么？对 play。
The XA with the dot, what does it represent? Time derivative. Time derivative.
A dot, we said that for simplicity, if we have dx
因为我这个才
to
一点点
dt,
嘛，这
we
个
show
应
it
该
by
是用那个
x dot.
秤。
And x dot means velocity, so it's velocity squared. X double dot is acceleration. Give me
Negative 24.95.
a negative 20.95 feet per second squared. If the problem is like this, which is just geometry taking derivative, it's simple. Wow! there was one more point. It said, what is alpha of AB? How can I find alpha? How can I find alpha? Question, how can I find alpha? Answer, instant center of rotation. If this point is coming down, this point is moving that way. Perpendicular, perpendicular, instant center of rotation is there, right? Say yes. Okay, if instant center of rotation is there, it means this bar is turning about that point at this configuration. If I have the acceleration of this point, it's equal to R alpha, or R alpha. So both of them are correct. Clear? Here. A of point A is equal to AB, let me call it C. AC times alpha of AB. Also, I can say A of B is equal to BC alpha of AB. Both of them are correct. Use one of them. Doesn't matter. Clear? The bar is turning about instant center. I have tangential acceleration of 2 points. 1 point is enough. Tangential acceleration at this point, at this moment. Velocity acceleration of this point is in that direction, which is perpendicular to the radius. Radius times alpha is acceleration. So the answer of these two must be the same. Alpha AB is equal to A of A divided by AC, which is equal to A of A, we had it 4 meters per second, 4 feet, divided by AC. AC is the same as this length, which was Y of B, 8. 1/2 radian per second square. As a double check, let me find from here. Alpha of AB is also A of B divided by BC. A of B, we found A of B, which is 24.95 divided by BC. BC is from here to here, which is XA, which is here, 13.86. 13.86. The answer must be the same. It's not the same. Something is wrong. What is wrong? What did we do here? B, C, A of B. A of B is wrong. Who gave me this number? A of B is wrong. How come one side is 4, the other side is 24? Not possible. That's right. Still the same thing?
Yeah.
24.
0.95.
One side is 4. Let's double check VB. VB was 10. One side was 6.
The one is 148.
Correct. 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 Okay, I don't see any problem. So what was this number? 24?
0.95. Negative 24.95.
So what is wrong in my equation here? Point A is turning about instant center of rotation. And its acceleration is in that direction. It doesn't have any other acceleration. So it is R alpha, AC times alpha.
AB is also 4.93。
I don't know. I think it is correct. If these numbers are correct, this is double check. One of them gives me that alpha, the other one must give me the same alpha. Something is wrong that I am not seeing them. So let me erase this. Take a photo up to here. I don't know what is wrong. Something miscalculated. 24 feet per second compared to 4 doesn't make sense. But you double check and the number is correct. Well, this is correct anyway, and the other one must give me the same thing. I don't know why it is not giving. BC. Something I don't see. I don't know. Look at this. If alpha is the same thing, BC is bigger than AC, then AB must be bigger than AA. I agree. AB, not 24 compared to 4. It must be proportional to the length. Okay, forget about the last part. This is another example. Okay, because it was an exam, so you can take a photo. This problem, I'm going to the next one. This was another one. This is actually beautiful and very hard. This one is beautiful and hard. Let me see if I have any other example. Yeah, exam 3 with solution. So let's look at this. The problem says if the slider block A is moving to the right at VA equals to 8 feet per second, determine the velocity of block C and B. First, look at A and B. What? Look at A and B and realize that A and B are two sides similar to this. Similar to this. A and B are similar to that. Let's take a look on solution. So it is from Hippler, 4th edition. This is the solution. Take a photo, complicated actually, ugly. Take a photo of solution. I'm going to next part of the solution. 1, 2, 3. Here we go, finished. This is another one. Compute the angular velocity of rod AB, angular velocity of AB, when theta is 30 degrees, the shaft of the center of the roller C moves toward at a constant V equal to 5 meters per second. That's a question. Take a photo, and that's the solution. I didn't see anything interesting. Exam 2 with solution. I like it. Take a photo for yourself and then move up so you see the rest of the solution. Here is the rest of the solution. Oh, long solution. So solution starts from here and then goes here. Okay. This is another example of conservation of energy. Nice one. Solution was easy. What is that? Oh my God, this is collision. So it's the same principle of a car is traveling at 14 meters per second. When it is 5 meters away from a wall, the driver applies the brake to all 4 wheels at the point of the skids toward the wall. If the crash into the wall takes 2.2 seconds, determine the average of impulsive force of the wall on the car. The car has a mass of 1.5 ton, and the coefficient of friction is 0.6. For the solution, include the friction impulse acting on the car during the collision. Okay, that's enough for today. See you tomorrow? Oh, no, there is nothing tomorrow, don't worry.
So how many questions are in the exam? How many
I don't know.